Throughout human history, one fundamental question has followed us. Are we alone in the universe? For centuries, this was a question for philosophers and dreamers, but that has changed. Today, this question is being investigated in the most advanced laboratories and observatories on Earth. And a recent discovery made by the James Webb Space Telescope has set off a red alert in the scientific community. 120 light-years away, a world called K2-18b may be hiding a biological secret. A molecule has been detected in its atmosphere, a molecule that, here on Earth, is an almost unmistakable sign of life. Could this be the moment we've all been waiting for? The first evidence of biology beyond Earth? In the next few minutes, we'll analyze the evidence, separate fact from fiction, and understand why K2-18b has overnight become the most fascinating planet in the galaxy. Stay with me. Before we talk about this explosive discovery, we need to set the stage. Who is our main suspect? What exactly is K2-18b? K2-18b is not another Earth. It's very different. It's about 8.6 times more massive than our planet and has a diameter 2.6 times larger. That places it in a fascinating category of exoplanets known as sub-Neptunes. These are worlds larger than Earth but smaller than gas giants like Neptune. It orbits its star, K28, right in the middle of the so-called habitable zone. That's the region where temperatures are neither too hot to boil water nor too cold to freeze it. In theory, a perfect place for liquid oceans to exist. And this is where the story gets really interesting. Because of its mass and density, scientists developed a hypothesis about K2-18, that it could be a Hycean world. The name sounds complex, but the idea is amazing. Hycean is a mix of hydrogen and ocean. The theory is that K2-18b could be a planet covered in a global ocean of liquid water, but with a dense, hydrogen-rich atmosphere. Imagine a colossal water world beneath a completely alien sky. For years, this was just a theory, a model. But to know the truth, we needed a tool capable of tasting the atmosphere of that world, and that tool has finally arrived. Enter the hero of our story, the James Webb Space Telescope. Webb's ability to analyze infrared light with unprecedented precision made this investigation possible. But how exactly does it work? Through a technique called transit spectroscopy. Here's how it works. When K2-18b passes in front of its star from our point of view, some of the starlight filters through the planet's atmosphere. Each gas or molecule in that atmosphere absorbs light at specific wavelengths, leaving fingerprints on the light that reaches the telescope. It's as if the atmosphere leaves a chemical barcode in the starlight. By analyzing this barcode, scientists can determine exactly what K2-18's atmosphere is made of, even from 1.2 quadrillion kilometers away. It's simply brilliant. And it was while analyzing this barcode that they found something extraordinary. Okay, now let's get to the heart of the discovery. The team of astronomers pointed Webb at K2-18 and waited for the transit. So, what did they find? First, the confirmations. They found strong evidence of methane and carbon dioxide. The presence of these gases, along with the absence of ammonia, strongly supports the Hycean world hypothesis. A liquid water ocean beneath a hydrogen-rich atmosphere is the most likely scenario to explain this chemistry. That alone would already be a fantastic discovery, confirming the existence of a new type of potentially habitable world. But the real bombshell, the discovery that made the scientific community hold its breath, was something else. It was the possible detection of a molecule called dimethyl sulfide, or DMS. And why is this strange-sounding molecule so important? Because here on Earth, DMS is intrinsically linked to life. The overwhelming majority of DMS in our atmosphere is produced by biological processes, especially by phytoplankton in the oceans. Think about that. We've found a world with a liquid water ocean, and in its atmosphere, a molecule that's on our planet screams marine biology. It's the cosmic equivalent of spotting smoke rising from a distant forest. The first thing you think isn't "what a strange geological reaction." The first thing you think is, "someone lit a fire." That's why the world is buzzing. DMS is considered one of the strongest biosignatures we could hope to find. But before we start drawing aliens from K2-18, we need to put on our skeptical scientist hat. So, did we detect life?
The short, honest answer is not yet. The key word in this entire discovery is possible. First, the DMS signal, while exciting, was statistically less robust than the methane and CO2 signals. The very scientists who published the study say the detection needs to be confirmed with further observations. The evidence is there, but it's not a closed case yet. Second, and this is the most important point, we're talking about a type of world that doesn't exist in our solar system, a Hycean world. Could there be unknown geological or photochemical processes unique to this type of planet that could produce DMS without life? The answer is maybe. Science works based on evidence, and we can't rule out non-biological explanations until we have overwhelming proof. But what about you? Based on what we've seen so far, what does your gut tell you? Is it life or some exotic geological process? Let us know in the comments below. Let's build a healthy discussion together. Now back to the main topic, what happens next? The story of K2-18b is far from over. In fact, it's just beginning. The research team already has more observation time scheduled with the James Webb Telescope. Their mission now is twofold. First, confirm the DMS. They'll observe again with more time and precision to see if the dimethyl sulfide signal becomes stronger and clearer. Second, they'll look for other clues, gases that could either support or refute the hypothesis of life, such as oxygen. The saga of K2-18b has become one of the most exciting scientific investigations of our time. Let's recap what we have. A perfect candidate planet, a Hycean world with a liquid water ocean. The right atmospheric ingredients, like methane and CO2. And the most tantalizing clue of all, a possible DMS signal, a molecule that on Earth screams life. However, we still can't say for sure. Science demands rigor. But for the first time in history, we're not just speculating anymore. We're collecting real data from a world that legitimately has the potential to harbor life. The search for an answer to the question, "Are we alone in the universe?" has shifted from philosophy to experimental science. If you were as fascinated as I was by this cosmic journey, don't forget to leave a like to support our work. And most importantly, subscribe to the channel and activate the notification bell, because the moment K2-18b is confirmed, you'll be the first to know right here. Thank you for traveling the cosmos with me. See you in the next discovery.